You're sitting in front of a computer. You don't move your hands. You don't touch the keyboard. Yet, the cursor on the screen moves, simply because you thought about it. Today, I'll tell you a short story about a tiny device that could change everything: the brain chip. Before that, you should know about the components of the brain chip. Let's start with what this tiny device is made of: biocompatible enclosure. Imagine a tiny case, almost like a strong shield. It keeps the chip safe inside your brain and makes sure your body doesn't reject it. It's sealed tightly, so no fluids or bacteria can get in. Battery. Just like your phone, it needs power, but instead of plugging it in, this chip charges wirelessly. You could wear a small charger on your head while you sleep, and by morning, the chip is fully charged. Chips and electronics. This is the brain of the brain chip. These tiny processors read your neural signals, translate them into data, and then send them out wirelessly to your computer or phone. Think of them as the translator between your mind and machines, threads with electrodes. These are ultra-thin wires, way thinner than a human hair. At the tip of each wire are electrodes, like tiny microphones, that listen to your neurons firing. There are over 1,000 of them, carefully placed so they don't hurt brain tissue. Okay then, how it is connecting to the brain. The chip has ultra-thin electrodes. These wires are placed on or near neurons in the brain. Surgeons carefully put these wires into the motor cortex or other target areas. Wait, do you know about the motor cortex? The motor cortex is the main part of the brain that sends the movement signals. The motor cortex generates electrical signals whenever you think about moving your hand, leg, eyes, etc. This ensures the chip can listen to brain signals linked to movement or thought. So these electrodes are positioned close to neurons, the brain cells responsible for sending and receiving electrical signals. By being placed in these regions, the chip can directly interact with the brain's communication system without damaging surrounding tissue. Once connected, the electrodes detect the tiny electrical pulses created when neurons fire, like when a person thinks about moving a hand or finger. These signals are then sent to the chip's implanted processor under the skull, where they are converted into digital data. Finally, the chip transmits this information wirelessly to an external device such as a smartphone, computer, or robotic limb. This process makes it possible to turn thoughts into actions, like controlling a prosthetic arm. Now, here's where things get really exciting and a little scary. Brain chips don't just stop at medical uses, like helping paralyzed patients move again. In the future, they could completely change how we learn, work, and even think. Imagine waking up and instantly knowing how to play the guitar, fly a plane, or speak Japanese. A brain chip could teach you skills by directly stimulating the right pathways in your brain, skipping years of practice. This means students could learn faster, workers could adapt to new jobs instantly, and humans could become super learners. But there's a flip side. Who controls these skills? What if companies start selling abilities as subscriptions, like pay monthly to keep your programming skills active? Or worse, what if someone hacks your brain and installs false knowledge? Now picture this darker possibility. Instead of seeing ads on your phone or TV, they appear directly in your mind. You're sitting quietly, and suddenly you hear a voice saying, "Hungry? Order pizza now." That's because the chip isn't just reading your brain signals, it's also sending new ones into your auditory or visual cortex, making you experience things that aren't really there. This could turn the human mind into the ultimate advertising space. It raises serious concerns about privacy and manipulation, where even your thoughts are no longer safe. So, brain chips could be humanity's greatest invention, curing diseases, restoring movement, and making learning effortless. But they could also be its most dangerous, opening doors to mind control, invasive ads, and corporate control over human skills. It's not just about connecting machines to the brain, it's about asking, who gets to control the connection?